Okay, hello. Today we're doing experiment 12, which is a elimination starting with this product. So the word regiochemistry refers to the different placement in which a bond can go. So actually, if you eliminate starting from this starting material, there's many different places that the double bond can be. So what we're going to do today is heat this in sulfuric acid, and we're going to get three products. So the product that is predicted to be the major product by Zaitsever's rule, which says that the more substituents an alkene has, the more stable it is, would indicate that this is the product. But we actually are going to have a few others as well. So there's also an option to have the double bond go there. And additionally, it's possible that the reaction could undergo carbocation rearrangement and the double bond could end up here, because we're going to be doing E1. And E1 has a carbocation intermediate. So anytime you have a carbocation intermediate, you open yourself up to a possibility of having carbocation shifts. So it's going to be up to you guys to decide which of these is going to be the major product and how much of any of these given minor products you're going to get. So the lab today would be a distillation. And so if you're doing a distillation, there are a few hazards to keep in mind, which Jonathan is going to keep in mind when he does this lab for you guys. Basically, first of all, since we're using sulfuric acid, that in itself is a hazard, so you're going to want to try to avoid contact with this. Don't inhale it. People have done that. Don't, if you spill it on yourself, take caution to rinse it off as soon as possible. Just be careful. This is not something you want on your skin. Additionally, in any given distillation, you want a way to remove your apparatus from the heat immediately if you have to, because if you're heating an empty flask, it could create fireballs. So Jonathan will be sure to have his apparatus on one of those blue jacks, and I'm sure he will be sure to clamp everything securely so that he can lower it in case of emergency with no problems. Yeah, over to you, Jonathan.
Alright, so as you can see here, I'm going to lift the hood sash up just a little higher so that we can get the camera in closer. I have my distillation set up ready to go. I have my 25 milliliter round bottom flask that's connected to the Y adapter. I will have my thermometer right in the middle, right around the spot where it's going to go into the condenser. I have my condenser then connected to the distillation adapter, which is going to be in my graduated cylinder. I have my condenser set up with the tube with the water that's going to flow into the condenser on the bottom and then flow back out on the top. I will be able to lower my hot plate in case of emergencies if I need to, so that way I don't boil anything over. And so I will add my cyclohexanol to my 25 milliliter round bottom flask, and then I'll be right back with you. So at this point, I've added about 4 milliliters of cyclohexanol, which is roughly 33 millimoles. And so now I'm ready to add my concentrated sulfuric acid. I have the dropper bottle with my sulfuric acid in here, so I'm just going to swirl this gently while I add about 20 to 30 drops, noting any color changes that occur. 2. As about 13 drops, it's starting to get a little bit of a yellow color. I'll continue swirling and add a little bit more. 14, 15. 21, I still, that yellow color has gotten a little bit larger, started to become a little bit more vibrant, so I'll continue adding to about 25. So at this point, I've added about 25 drops of sulfuric acid. I'm ready to reattach it to my distillation setup and get it distilling. I have everything all back set up. You can see I have my stir bar in there, stirring my solution. I have the thermometer set up. It's roughly 23 degrees, which is about room temperature right now. I have the water flowing through my condenser, and as you can see, I don't have any air bubbles in the condenser. So once I turn the water on, I made sure to eliminate all the air bubbles, and then I turned down the water to prevent excess water waste. And so now I'm going to monitor to the temperature in the with the thermometer, and monitor until I get about 2 milliliters of liquid distilled. Back here, we're about 15 minutes into this reaction. As you can see, once I raise the fume hood up, the colors change pretty dark. And since the last time I've lowered the thermometer a little bit, because I had it a little bit too high, but it still stayed about 23. Now, right now it's hanging out at 26, so it should be distilling here shortly. I will get back to you whenever we're ready to start distilling and make sure that you can see that process. So at this point, it's been about 25 minutes in the reaction, and in the last minute, it's jumped from about 23 degrees to almost 75 degrees. So I do expect that it will be distilling here shortly. We can kind of see a little bit of condensation forming in that Y adapter, so that's a pretty good indicator that it should be distilling shortly if it has not already. So I will be back and let you know how long it was before it started distilling. So it's only been about a minute since last time you saw me, but as you can see, we're starting to get a little bit of droplets forming. It's definitely not going at 2 drops per second yet, so I'll keep the heat on. But in reality, the slower that I'm able to distill it, the more pure the compound is likely to be. So this is good. We will continue to watch these drops, and then once we get to about 2 milliliters, we'll pull that off. At this point, it's still about 77 degrees, and why might that be? That if you compare that to the boiling point of your alkene product, what might be the reason for those temperature differences? So at this point, we are done with our distillation. We have about 2 milliliters in our graduated cylinder. So I'm going to lower the hot plate down, making sure to keep care of my condenser, and then turn it off. And then also turn off the water. So at this point, I'll be right back with you once I get some sodium sulfate, but I'm gonna pour my mixture into a Erlenmeyer or into a vacuum adapter flask in order to add the desiccant and remove some of that water. So if you look closely at the bottom of my round bottom, you'll see that there's a very little water droplet in there. So instead of trying to use just sodium sulfate to get that out, I'm actually going to take a pipette and see if I can pipette that off before I add the sodium sulfate. This probably will result in a little bit of product yield loss, but since I'm not as concerned about product yield as I am about removing the impurities, it's not as big of a deal. So. So it looks like I got most of it, so I'm going to go ahead and add the sodium sulfate now. I will put that water that I just pipetted up into this aqueous waste. So now I'm ready to add in some sodium sulfate to complete, try to make it go to dryness. So I'll add about a pea-sized amount to start with, and then swirl and see if it's still clumping up, and then make a determination if I need to add more. John and Shay, what do you think? Do you think I should add a little bit more?
What are we adding?
Sodium sulfate in order to dry it.
I think add a little bit more.
So I'll let this sit for a few minutes and see how it goes, and then if I think that it's not clumping anymore and that it's pretty dry, then I will decant or pipette off my hopefully just alkene solution into a pre-weighed vial so I can get the weight of it. It's been about 5 minutes since I've been letting it dry, and it looks like it's not clumping anymore. So now I'm gonna transfer it into a vial. First, I'm gonna tare the vial, so I'm gonna have it on the balance. registers about 8.748 grams. I'll close the door just to make sure that I don't have any influx of air. Tare it at 0.0. Now I'm going to pipette or decant off my my liquid from the drying solution.
Wait, Miss Rogers, here, get up to this spot. Try to get it away.
So the final weight of my product is roughly, or is going to be 1.255 grams. So I'll use that weight whenever I'm determining my my percent yield when given that I used 4.0 milliliters of starting material. So now I have my clean NMR tube, so I'm ready to add some product. Typically, we'd recommend about 10 milligrams of product. Whenever you're dealing with a liquid solution, though, you should use roughly 2 to 3 drops. So once that goes to the bottom, you'll see that it's roughly about the same amount of solid material that you would normally use, in that it goes just above the curvature of the NMR tube. So to this, I'll add about 0.5 milliliters of chloroform, roughly up to around here, and then I'll be good to do my NMR, which you guys will be getting the results probably on campus. It was nice working with you. And now, of course, I'll finish cleaning and then break down the lab and be good to go. At this point, my hot plate is still a little bit warm, but my round bottom flask is cooled off sufficiently that I can clean it. That should just be remaining sulfuric acid, so I'll add that into my aqueous waste, and then I'll clean everything with acetone.